Okay, I'm going to work through the applications of exponential functions, the show your work questions. So we'll start off with question 1. Okay, so your friend purchases a new car which costs them $36,000. For every year after it is purchased, the car loses 17% of its value due to depreciation. What is the value of the car after 64 months? Okay, so setting it up, we're using our exponential equation that we have been using. Okay, for this, when we're dealing with money, we're going to set it up so that, and so since it's depreciating, that means that it's going to be 1 minus r to x, and then a is the price of the actual car. So if I put all this in, I get 36,000, 1 minus 0.17, and then if we're looking at after 64 months, but our 17% is for each year. Okay, so we got to change the 64 months into years, so divide 64 by 12, we get 16 over 3. Okay, we're doing this, we're taking subtraction because it's not 17% that's left over each year. It's going to be the 83% that's left over each year. Then we can work this out. 1 subtracts 0.17 to the power of 16 over 3. Make sure when you're entering this in your calculator that you're putting those in brackets. And then times it by 36,000. We'll get that the car is worth 13,326.59, which, if you check on the solutions, is the answer for that. Okay, now number 2. So a certain type of bacteria, given a favorable growth medium, doubles in population every 6 hours. So we first want to find out, after 2 days, there are 4,096 bacteria. So we're going to try and find the initial amount of bacteria. So the initial amount, so again, y equals a times b to the x. This is always our initial amount. So like what we used up here, that was the initial car amount. Here is what we're going to be finding out. And so since it doubles, we know that our b is going to be 2. Okay, and then, so after 2 days, so if it's 2 days, my x is going to be 2. Leave a as is, and then after 2 days, there's 4,096. Okay, so I need to rearrange this by dividing this side by 2 squared. So divide this side by 4, divide this side by 4. My a value will then be 1,024. So that's the initial bacteria. Okay, and then for b, how long would it take for there to be 65,536 bacteria? So that's going to be my y value, 6. And because we solved our initial in the first one, we're going to use that for a, times it by a, and we're trying to find out how many days it will take. Okay, so I'm going to take this and bring it to the other side. So I'm dividing this side by 1,024. That cancels out, but then I'm also dividing this side. When I divide that, I get 64 equals 2 to the power of x. When I'm trying to bring x down, what I'm going to use is logarithm. So I'm going to take the log of both sides. And then when I take the log of 2x, x falls down in front of the log, so I just get log 2. Then I want x by itself, so I'm going to divide this by log 2 and divide this by log 2. Those two cancel out, and I end up with 6 days. Okay, so it's 6 days, or if I times it by 24, I'll get 72 hours. Okay, and now number 3. Steph Curry makes a 3-point shot just before halftime of a basketball game. The shot goes through the 10-foot tall net, and since it is halftime, nobody is around to collect it. Every time the ball bounces, it rebounds to 75% of its original height. What is the height of the ball after it is bounced 4 times? So for 3, we're going to set it up again. So we know our initial height is 10 feet. And then we know that it's bouncing 75% of the height before. So we're just going to put this as 0.75%. And then to the power of x. Okay, so for A, so x here is representing how many bounces there's going to be. So for A, it's saying 4 bounces. So we're trying to solve for y when the ball is bounced 4 times. So we're going to put 4 in for x. And then we'll solve that. We get 3.16 feet. So on the 4th bounce, it will bounce up 3.16 feet. Now for B, so we're looking at how long it will take for the height of the ball to be 1 foot. So we're finding out how many bounces it will take for the ball to bounce up 1 foot. So we're going to put 1 in for our y, put our initial in for A, keep our percent the same, and this time we're solving for x. I'm going to bring the 10 to the other side. So I have 1 over 10 equals 0.75 to the power of x. And then I want my x to come down, so I'm going to have to use the logarithm again to both sides. So I'm going to take the log of 1 over 10 equals, and then when I take the log of 0.75, the x will fall down in front of it, so I get x log 0.75. Divide both sides by log 0.75. These cancel out. And I end up with approximately 8 bounces. Okay, so it takes 8 bounces for the ball to go up 1 foot. Okay, now for the last question. In 2018, it was predicted that the population of Sudbury, Ontario would increase from its current population of 165,000 to a population of 180,000 people by 2048. Assuming this model's exponential growth, at what rate is Sudbury's population growing? Okay, so for 4, we're going to use okay, we're trying to solve for r here since we want to know the rate. We are given the new y value, so the new population number, which is going to be 180,000. And our initial one in 2018 was 165,000. Okay, so since this is exponential growth and not decay, we have to do 1 plus r instead of 1 minus r. And then for our x value, we're looking at the number of years in between. So between 2018 and 2048, that's 30 years. So our x is going to be 30. Okay, so I'm going to take this to the other side by dividing both of these sides by 165,000. And then when I divide 165,000, I cancel these two out. And then I get 1 plus r to the exponent 30. Okay, so when I bring in this over, I'm not going to use logarithm here because we can just use a root, the 30th root. So I'm going to bring this to the other side by taking the 30th root of this, which I will do here also. This will cancel with this out. Okay, so you can solve for this and then bring that 1 to the other side by subtracting. This will give me, it comes to 0. 0.0029. So then as a percent times it by 100, this is going to be approximately 0.3%. And that's all you have to do for that one.